Are you or someone you know struggling with long COVID? Do you think you or someone you know may have it? Have you ever wondered what's causing long COVID symptoms and if there's anything that could be done? If so, you don't want to miss today's episode because we're diving deep into long COVID and exploring how functional medicine may be the missing piece of the puzzle that you need to turn things around. Welcome to the Hashimoto's Doctor Podcast. You're now part of a growing community of people determined to take their health back through education and self-empowerment. But because of the healthcare system today, we don't have access to the types of healthcare that we want. So we have to do things differently. We've got to do things smarter, and we do that by becoming our own advocates. This podcast will give you the perspective and thoughts of one of the world's leading Hashimoto's doctors. So let's get started. Welcome back to the Hashimoto's Doctor Podcast. I'm your host, Brad Shook, and today we're going to get into a topic that's been making headlines worldwide, and that's long COVID, or COVID long haul. We'll be discussing the intriguing connection researchers are uncovering between long COVID and our gut and lung health. We'll also discuss how functional medicine might hold the key to improving these symptoms. So if you're ready, let's dive in. Today, we're diving deep into an absolutely massive problem, and that is the world of long COVID. If you ask anyone that you know, what is long COVID? They're probably going to either tell you they don't know, or they're going to say something like, isn't it just like continued COVID symptoms? And that's kind of true, but it's also not exactly the case, because the symptoms that you have when you experience COVID or you're infected with COVID or with SARS-CoV-2 virus, it's not the same thing that might persist later. And this is because there are underlying pathophysiological or biochemical mechanisms, immune system mechanisms, disruption with our GI tract bacteria and GI tract lining or the intestinal barrier, as well as other problems that we'll talk about that could be triggering and driving these persistent symptoms. And this is really important to understand, because if we are going to do anything to help people improve their quality of life, turn this around, this massive problem around, we need to be able to look at these symptoms, categorize them, and then formulate specific strategies based on what's happening to these people. And this is what I hope to help give you some clarity and give you some specific strategies that you can use to help yourself or someone that you may love. So I think the first thing we need to do is just start by defining what is long COVID. And I looked over various definitions that are out there, and I think the World Health Organization has a good definition. And they say that long COVID is the persistence or the development of new symptoms 3 months after the initial SARS-CoV-2 infection. And these symptoms have to then last for at least 2 months and have no other explanation. Okay? So that's a pretty good definition. It's very broad, it's very vague, but that is the definition. Now they go a little bit further and say, there are really 4 categories of symptoms that have been identified, and how we recommend that you kind of observe these symptoms through this lens. So they do recommend categorizing these symptoms. So the first category are symptoms due to organ damage, and this could be from the acute infection when you first get it, causes massive inflammation of the lungs, and that can cause damage to the lung tissue, which then results in scarring or fibrosis, and then there can be long-term consequences from that, and that's the first category. So symptoms due to organ damage. The second category are symptoms due to the treatment of COVID-19. Now, this could be, a consequence of something like being placed on a ventilator that would cause damage and then persistent symptoms. The third category are symptoms due to the worsening of an existing condition. And this could be a case where, let's say you have cardiovascular disease and you get COVID and you develop blood clots. And then that worsens the cardiovascular condition, and then there are persistent problems from that. And our last category are really unexplained symptoms. And this is where they don't have a clear mechanism right? The other things that we've mentioned, there's a more clear mechanism of cause for persistent symptoms, but these are things that are really can't be explained yet. And I think the information I'm going to share with you in this podcast will, I mean, to me, a lot of these researchers, there are some researchers that have uncovered what I think are likely causes of many of these vague symptoms that cannot be explained. And this is the world that I live in, because I mean, I work with people that primarily have autoimmune conditions. And most people that have autoimmune conditions live with these problems for years and years before they're diagnosed. And it really, they have these symptoms until it's so bad, their autoimmune conditions are so bad that it's undeniable what's happening. And so in that world of autoimmunity, one of the most important things we can do is help people to identify these problems early on so that they can then make changes to their diet, lifestyle, and even using temporary nutritional supplementation to help mitigate and dampen the immune response and help to slow the progression or put it into remission if possible. And you see this, you see these vague symptoms all the time. And it's very tricky because it's hard to diagnose, because the symptoms that people experience often overlap with other conditions, and it can be hard because there aren't real clear biomarkers in most cases. Okay, so this last category of symptoms is, it's the world that I live in on a day-to-day basis. It's these mysterious symptoms that can't be figured out, and we need to dig deeper. So I think that's a good definition. That's a good starting point. And of course, it's evolving, and it will evolve over time as more research is created. Now, let's talk about, now that we understand these symptoms, let's talk about the hypothesized causes of long COVID that researchers have started to uncover. And I think this is where it's at. I mean, I think these researchers have really are looking at and have drawn attention to what I think are the most likely underlying mechanisms here that are creating these vague symptoms anyway, that are that fourth category of symptoms that we talked about with fatigue. I think these are the likely drivers of those issues. Okay, so first of all, I'm just going to go through and I'm just going to tell you the mechanism, the name of the mechanism, and then I'll come back to it and we'll go a little bit further into the explanation of what it is and how it may be contributing to these persistent symptoms. So number one is immune system dysregulation, loss of normal immune function. Number two is microbiota dysbiosis. Now, your microbiota is this grouping of all the organisms in your digestive tract. Number three is autoimmunity due to molecular mimicry. And molecular mimicry is just an immune term for how autoimmunity may develop as a result of an infection, okay, which we know happens. That's well established as something that occurs with viruses, other viruses than SARS-CoV-2. But SARS-CoV-2, there's been some research and information out there as to how it may trigger and contribute to autoimmunity, and it's a real possibility as well. The fourth hypothesized mechanism, right, researchers are looking at, is blood clotting and endothelial abnormalities. And I think this speaks for itself, like blood clotting, that can form as a result of the infection. And number five is dysfunctional neurological signaling. So these are the top five proposed mechanisms thus far that might be contributing to and causing long COVID. So let's talk about these in just a little bit more detail. So number one, immune system dysregulation. And if you think about this, just imagine that your immune system, it's this complex system, and it has to be coordinated. Your body, your immune system, it's a coordinated effort for your immune system to function properly. When you're infected by something like SARS-CoV-2, your immune system should ramp up its production of immune cells that specifically fight off a virus, which creates inflammation, which you want. You want the inflammation to help get rid of the virus. You just don't want too much inflammation. So you want this ramping up of the inflammation. You want the virus to be eliminated, and then you want the immune system to the inflammation to resolve, to diminish, and come back to a baseline where the immune system is not producing inflammation. It's just surveying. It's in a surveillance mode. So it's looking for problems again. So it did its job. It produced inflammation to get rid of the virus. Virus is cleared, and then their inflammation resolves and comes back to a baseline. This dysregulation or loss of normal function may actually create an environment where the immune system is either hyperactive, it's too active, and there's still a higher baseline of inflammation, and this persistent inflammation is creating problems systemically throughout the body. It's creating problems for the brain, the endocrine system, the nervous system. Everything is dysfunctioning to some degree because of persistent inflammation. Another way that this may be affecting us is that we may have some immune suppression afterwards. So the immune system is unable to properly surveil and control viral diseases like, for example, infections like Epstein-Barr virus that can be a latent infection that can lie in the tissues. Herpes virus family is really what I'm talking about here. They are known to be able to lie dormant in tissues, and then when the immune system is suppressed, they reactivate. And you'll see this if you have herpes simplex virus and you have outbreaks. The HSV1 and 2 are similar in that you can have like an ulceration on, let's just say, your lips, for example, if the virus becomes reactivated. So if the immune system is suppressed and it cannot keep these latent viruses that are kind of hanging out in our tissues and just waiting to reactivate when the immune system is suppressed, you will see some problems there. So this is another potential mechanism where the immune system is suppressed and it might lead to reactivation of these underlying pathogens like Epstein-Barr virus. And this can create a lot of problems for the body, because if you've ever had Epstein-Barr virus, you know that it creates massive fatigue, and it definitely can reactivate. That's well known. There are panels that you can run that look for reactivation of the virus. But this is absolutely a major issue, immune system dysregulation. And we're going to talk about next, the second hypothesized mechanism is Microbiota Dysbiosis, and this is an imbalance in the GI tract flora. It's everything there. It's not just the bacteria. It's the viruses that are present there. It's the fungi that are present there. It's the parasites that may be present there. It's the microbiota. It's not just the bacteria that are present. They have this intimate role with immune system function. So let's go there next. So number one, immune dysregulation. I think that's a major issue, could lead to persistent inflammation, and could also, there may be suppression of the immune system post-infection, which may allow other viruses to reactivate. The second hypothesized mechanism is microbiota dysbiosis. And you think of it this way, our gut is really home to trillions of microbes. And with long COVID, this community of microbes might get disrupted. And this can affect how the immune system interacts with viruses, including SARS-CoV-2, because it's really interesting. I'll talk about it. I'll talk about it in just a minute. We'll go into more detail on how this microbiome has this really profound and significant impact on the immune system. And this, again, this is this environment inside of our digestive tract, and our immune system is not necessarily in our digestive tract. It is in the bloodstream. And so, how does this environment, how does this ecosystem in our gut affect the immune system? And we'll talk about that in more detail in the next segment. But it's a really important thing to focus on. The third mechanism is autoimmunity due to molecular mimicry. Now, this is where the immune system gets confused and attacks our own cells. And this can happen because parts of the virus resemble parts of our body. And this was there was a letter published in Clinical Immunology, which lists several tissues that could be targets of this misguided immune response. And it really is amazing because there are a ton of different human tissues that it appears that COVID, the virus, SARS-CoV-2, has mimicry with, meaning that if your body reacts to SARS-CoV-2, the antibodies in your blood may actually attach to some of your own tissues because of similarity of protein sequences and structure. This is called molecular mimicry. It's a well-known immunological mechanism for the initiation and the persistence of autoimmune conditions. So this is a major issue, and there are a ton of different human tissues that have mimicry. So this could be, maybe the virus triggers autoimmunity, and then the autoimmunity is the thing that's activating and driving these persistent symptoms. And because the virus has similar protein structure to a ton of different tissues, many different tissues, including neurological tissues, it could be the primary reason for these persistent issues. Now, our fourth category or hypothesized mechanism here is blood clotting and endothelial abnormalities. So just think of it this way. Imagine like tiny clots and dysfunctional blood vessel linings. That's what your endothelium is. It's the lining of the blood vessel. And this is absolutely something that can happen with long COVID. And this could affect blood flow and oxygen delivery and nutrient delivery. And obviously this could be a major problem and cause some persistent issues long term. And then the fifth mechanism that has been proposed is dysfunctional neurological signaling. And this is where COVID might mess with basically the communication between our brainstem and our digestive tract. And really, even autonomic, like the involuntary nervous system, can really affect that system as well. So dysfunctional neurological signaling. So those are the five mechanisms. And then just again, I'm going to go through it one more time. Immune system dysregulation, disruption of your microbiota, so the dysbiosis or an imbalance in your gut flora, right, which is a combination of things. It's not just the bacteria, it's the entire community of your gut. The third thing is potentially autoimmunity triggered due to molecular mimicry, which could obviously create persistent symptoms. The fourth mechanism that's proposed is blood clotting and endothelial abnormalities, these tiny clots and dysfunction of the blood vessels. And the fifth mechanism would be neurological signaling issues or dysfunctional neurological signaling. So as you can see, these mechanisms are complex. It's clear that we need more research, but this is a great start because there's so much that you can do with this information that's already been put out there and as a hypothesized mechanism. I think that one of the most important areas of focus should be on our second mechanism, Microbiota Dysbiosis, or bacterial, but really this is probably bacterial imbalance. And there's some great research that's come out on this, and I think it can be really helpful to us. And this is where we're going to focus our efforts and what we're going to talk about next. Okay, so now that you have a better understanding of long COVID, we need to talk about something that may be the key to improving long COVID, and that is the microbiome. Inside each of us, we have this incredibly diverse ecosystem of all kinds of microbes. I'm talking about the microbiome, and this is a community of trillions of bacteria and other microbes that are living in our digestive tracts. And you might be thinking, like, why do we have a microbiome? Like, why do we have these bacteria? What's the purpose of this? Why do they matter? And it turns out that these tiny organisms may actually be the key to our health. So I know that may seem impossible or something new that you may not be familiar with, but the reality is that there are several ways that the microbiome influences our health, and they're really it's a symbiotic relationship. They help us, and we should be helping them. So let's talk about some of the things that the microbiome that it does to support our health. And there are three things that are really key to understand here. And as you know, this is an evolving science. Microbiome research, I would say, is we've made a lot of progress, but there's still so much to learn. But some of the key things that we've learned thus far that look and appear to be a factual information that does have a significant positive impact on our health, as long as we have a healthy microbiome, are these three things I want to discuss briefly. So first of all, the microbiome helps to keep us healthy because it plays a protective role. Now, if you think about this for a second, we have all these bacteria, and they can actually grow and outcompete other bacteria that could be pathogenic if they were to grow or be in larger colonies. And so the good bacteria basically outgrow some of the potentially dangerous bacteria that could actually cause problems for us. So they protect us that way. But they also do something else that's really important, and they help to educate and train our immune response, which is absolutely fascinating that they do this. And this means that these bacteria are involved in something called immunomodulation. So they help our immune system to respond appropriately to something that's foreign. And this is critical because one of the things that seems to be an ongoing theme in a lot of health problems, especially autoimmune conditions, but also long COVID, which does also appear to have some really strong evidence that a lot of people suffering with the problems that are and the symptoms associated with long COVID actually have an autoimmune condition that has been triggered from the SARS-CoV-2 virus. So these bacteria, one of the things that they do is they really help with this immune system modulation, which is kind of like fine-tuning our immune responses so that they're, it's appropriate. So they are critical for our immune system, and they play this protective role. Now, the second thing that these bacteria do is they are really metabolically, they're incredible. They can actually be thought of as a metabolic organ. These bacteria can literally be considered another organ. And one of the reasons, and I say metabolic, they're a metabolic powerhouse. They do all kinds of things, and they produce all kinds of vitamins and different types of what we call postbiotics. Postbiotics just means once the bacteria take fiber or food or polyphenols, these different colorful compounds in food, and they metabolize it, they produce a product, a byproduct, and these are called metabolites. And these metabolites, a lot of them are extremely beneficial to our health. So you think about it this way. They are a metabolic powerhouse. They can be thought of as an extra organ. They help us to extract energy from the food that we eat. They make different types of vitamins. They produce these postbiotics, which I've talked a little bit about, like short-chain fatty acids. The main one that has been researched, I believe, I would say the most is butyrate. And butyrate and these short-chain fatty acids are proving to be crucial for our gut health and immune system function. They keep the intestinal lining healthy. And the intestinal lining, all of our mucous membranes are a selectively permeable barrier system. So they basically let things into the body to help the body with optimal functioning, and they keep things out that would trigger inflammatory responses or be harmful. So keeping our linings healthy is absolutely critical. Absolutely critical. This is something that's absolutely critical with, when I'm working with people that are autoimmune and we're trying to dampen their autoimmune response or trying to get them, as healthy as possible. One of the key things that we focus on is improving their barrier systems, which your barrier systems are immune system barriers. Your intestinal lining, that's an immune barrier. Your lung lining, that's an immune barrier. From your mouth all the way through to your anus, that is lined with a mucous membrane. that has bacteria. For the most part, there's some parts of the GI tract that are have less bacterial concentrations, just simply due to the acid and other things that are present there. But throughout the entire digestive tract, you have this one cell layer thick lining, the intestinal barrier, and then on top of that, you have it's complex. I mean, you can look at different pieces of literature that will show you the layers of mucus and the different composition of those layers. But there are primarily two mucus layers that are on top of that one cell wall thick lining, that mucous membrane, and that mucus layer is absolutely critical for the function of the barrier. The mucus, there are all of these different bacteria in the gut. These bacteria, they have symbiotic relationships with one another. One bacteria that has been, is proving to be a keystone bacteria is Akkermansia, which is a mucus-producing bacteria. And the production of the mucus helps the mucous membrane, but also there are other bacteria that feed on that mucus, and there's this symbiotic relationship. So there's it's a very complicated system that we don't yet fully understand, but we do know that these bacteria play a protective role. They are metabolically function as an organ and do all kinds of wonderful things for us. And then the third thing is something that you may have heard about, you may not have heard about, but they also influence our behavior and mood. And that is just, if you think about that, like these bacteria in our gut literally can have an influence on our behavior and mood. And this might be surprising, but our gut microbes do have an influence on our behavior and mood because they are part of a communication system between our gut and our brain. And this is commonly referred to in scientific literature as the gut-brain axis. And this is absolutely fascinating if you think about this. I mean, when I learned about this, everything in the body's connected. And I've used this analogy for a long time where if you imagine a spider web and you just touch the corner of a spider web and you just gently move it, you're going to move that corner or the part that you're touching more, but the rest of the web will pull with it. So everything in the body's connected. I mean, there's nothing that's just in pure isolation. And if you only think of the body and the systems of the body and biomarkers that you might be looking at, and if you only think of those things in isolation and you're not trying to understand or take into consideration all these external and other factors, other systems that could be feeding into this process and causing the outcome that you're observing, then you're missing. I think you're missing the big picture, and you might be missing the opportunity to really improve your health. But if we coming back to the gut-brain axis, this is fascinating because the brain and the gut, they communicate a few different ways. So they communicate through neuron signaling, so they directly through a nerve, and the primary nerve is the vagus nerve, and this connects the gut and the brain together, and this signaling happens through the nerve because of chemical changes within the nerve that causes a propagation of a electrical impulse. So this is done through neurotransmitters or chemicals that allow a signal to propagate through neurons and through a tract of neurons, which is the vagus nerve. And this is a two-way signal. Now, this gut and brain connection also is able to communicate through endocrine signaling. And so this happens via different hormones and then regulatory gut peptides that are produced in the digestive tract as well. So because this goes into the bloodstream, and it is systemic, and it has an effect on the brain once those hormones and then those regulatory peptides reach the brain. They have a systemic effect. And the third thing is, which we've already kind of touched on, is through the immune system. Now, because these bacteria and this microbiome, this community of microbes, because it produces all of these postbiotics and these vitamins and it has an influence on the immune system and the health of your digestive tract and the composition of what is happening inside of your intestine. It has an effect on the immune system, because you have a particular type of cell, of immune system cell, that will make its way to the edge of your intestinal lining, or this one cell wall thick barrier system. And what it will do is it will make its way to this lining, and it will create a finger-like projection that will actually go between the cells. This is just amazing. Learning this to me was so fascinating. And this cell will sample your GI tract environment. It will actually sample what's going on there, and then it will pull this finger-like projection back into the cell with a sample of the GI tract, environment, what's happening in the gut, and it will take this into the bloodstream where other immune cells will observe or will be trained on what this particular cell, which is called an antigen-presenting cell, what it sampled from inside the gut. So it's literally your immune system is sampling what's in the gut, and then that is training and educating the immune cells on what to do and how to respond. And then based on what the immune system sees inside the gut, it then produces these they're proteins, immune system proteins, that are signaling molecules. They're called cytokines. And these signaling molecules will then influence the type of immune cells that are made, and the immune response as a whole really can be influenced very significantly through this process. So you can see the bacteria in our gut are just absolutely critical to our health, and they can play a protective role. They also make different types of metabolic compounds and things that are helpful for our gut. They influence our behavior and mood a lot of different ways through this gut-brain axis, which, again, is direct neuron signaling through the vagus nerve. It is also done via hormones and these gut peptides. It is also immune-based. So then you have this, this really complex communication between the gut and the brain. So now think about this. Of course, the bacteria do all these things for us, the microbiome. But imagine if this coordinated symphony within our gut is out of tune, or it's not in sync. This is what we call gut dysbiosis or imbalance, where the microbes in the gut is disrupted. And this can have, obviously this can have a lot of far-reaching effects on our health, and it can change our susceptibility to infections and respiratory diseases, because it is so significant, its impact on our immune response. So let's talk a little bit about how the immune system responds to microbes. And this is, now that we kind of have an understanding of how the microbiome influences the immune system, let's talk about how the immune system responds to microbes. And keep this in mind, the importance of the microbiome here. So our immune system will, once we're exposed to a virus or viral components, our immune system can identify viruses and viral components through special receptors. Okay, so you have these receptors called pathogen-associated molecular patterns, or PAMPs for short. You'll see that in the scientific research. And bacterial metabolites, we talked about the bacteria make these things called postbiotics, which means after, right? After the bacteria break down components of our food, fiber, polyphenols, all these colorful, different compounds that are in food, and other things but they make metabolites. So they basically utilize, eat, metabolize these different compounds that are primarily from our diet, and then they make something, a postbiotic. And we talked about how one of the most significant are short-chain fatty acids, and the most, again, famous being butyrate. And they have this immune modulatory or balancing influence. with it, when you're deficient in butyrate, like one of the things that I'll look for whenever I do testing is that if butyrate or the short chain fatty acids are low, then that is a if they're not in a normal range, that is a real problem, because we want to improve the gut bacteria. We want to have normal and healthy levels of butyrate to keep the intestinal lining healthy, to help with this modulation of the immune system. So it's a real important thing to focus on. But it has this immune balancing response. And this is important when we're talking about a respiratory virus, because you might think, well, what's the connection between the gut and the lungs? And you might already be able to piece, part of this together, because the immune system, the influence of the microbiome in the gut on the immune system is what we've already talked about. It's very important connection. But there's also, your lungs are also, the lining of your lungs, it's very, very similar to the lining of your intestinal tract. It's an epithelial lining, and you have your own a microbiome in your lung. And so similar types of issues can arise in the lung that also happen in the gut. So when we're talking about the gut and the lungs, there is also what's been referred to as the gut-lung axis. And that's this, again, bidirectional, similar to the gut-brain, bidirectional. The lungs can communicate and have an impact on the gut, and the gut can communicate and have an impact on the lungs. And so this is referred to as the gut-lung axis. And this means that what happens in the gut doesn't stay there. It can influence the health of our lungs and vice versa. So if the gut microbiome is out of balance, and we have the wrong bacteria present, and if these bacteria are not the type of bacteria that make short-chain fatty acids, like butyrate, which we've talked about is essential for health, then a normal immune response is going to be less likely to occur. That could then, if you don't have this immune modulatory effect that we talked about, then that could drive inflammation and set the stage for a unfavorable or a bad response to the SARS-CoV-2 virus, and that may lead to problems like those we see with long COVID. Because if the immune system is not able to, if the immune system is not able to respond to the virus appropriately, and then to come back to decrease the inflammatory response and come back to a baseline, then you could have more persistent inflammation. You could have an exaggerated response and have more inflammation and more tissue damage, and it could be a factor that contributes to a worse response to SARS-CoV-2. So this is something that the researchers are really looking at, and that I think, based on everything that I've read so far, I think this is one of the most important things that we need to be looking at: is how can we improve our gut microbiome. It's one of the most important things I think we can look at, and use that, optimize the gut to try and help the immune system respond appropriately. So, okay, let's bring it back. In summary, think about it this way: our gut microbiome is like a metabolic organ. Okay, it protects us, it helps us metabolize nutrients, it influences our mood, it communicates with our immune system, it does all these really critical and important things. When it's out of balance, it can have wide-ranging effects on our health, including our susceptibility to pathogens and different types of infections. So what I want to do is, in our next segment, I want to delve into how gut dysbiosis or imbalance in the gut is linked to the neurological manifestations in long COVID, and how understanding this connection opens a lot of different pathways for managing and potentially overcoming long COVID. So stay tuned. In this segment, we're going to explore the intricate connection between gut dysbiosis and long COVID. And we're going to focus on its neurological manifestations. And remember, dysbiosis just means an imbalance in the gut microbiota. So let's start with one of the consequences that has been observed when we have gut dysbiosis, and that is inflammation. So inflammation is really turning out to be a key player in long COVID. And when you have increased levels of inflammation, it is really a systemic impact on many, many systems of the body, and it changes and shifts your biochemistry in very interesting ways that we continue to learn about. And one of the things that we see is that it's a key player with long COVID, and that it can shift enzymes that cause a significant change in the way that tryptophan is metabolized. Now, if you don't know, tryptophan is an essential amino acid. It's one of the building blocks of the proteins of our body. It's normally used to produce serotonin in the body. And serotonin is a neurotransmitter that it really contributes to feelings of well-being and happiness. And what happens is when there's inflammation, there's this persistent inflammation, your tryptophan metabolism can be shunted away from the production of serotonin instead of, towards this really helpful neurotransmitter that makes us feel better. And it can be shunted away from that towards what are called neurotoxic metabolites. And these neurotoxic metabolites are, just as they sound. They're toxic to the neurons or the nerve cells throughout our body and in our brain. And this shift in this tryptophan metabolism can have significant effects on our neurological health. These increased levels of neurotoxic metabolites can create a number of symptoms. Some of the symptoms are depressed mood, irritability, increased susceptibility to stress, poor sleep, and even things like decreased concentration. So think about this. These symptoms are extremely common in people suffering from long COVID. And we know that one of the characteristics with long COVID tends to be that there is an increase in inflammatory levels. So optimizing immune response and inflammation is probably going to be one of the key things that needs to be done to support people that have long COVID. So now, keeping that in mind, let's discuss how the composition of the gut microbiota can influence the immune response to viral infections. Okay? The research suggests that a healthy, balanced gut microbiota can support an effective immune response and lead to better outcomes following a viral infection. Now, take that in for a second. This is a really important point. That if you're a healthy gut, balanced gut microbiota, that it can really have a significant impact on viral infections. And some of the characteristics that researchers have identified and that they think are these key factors to help us have a better response to viral infections are the following. There are higher levels of regulatory molecules, and there are lower levels of these molecules that produce inflammation, or what we'd call pro-inflammatory molecules. And so they have characterized a low-risk microbiome. So a microbiome that they believe is lower risk for a negative response to a virus. So this is a better thing. This is what the researchers believe is probably a better microbiome if you're exposed to something like SARS-CoV-2. And again, these are all hypothesized, but I think that based on what I see here, this seems to make a lot of sense physiologically. And in my practice, through telemedicine, what I have observed is that when we improve and we can optimize gut health and people's daily habits and daily rhythms, their schedule, that we can see major changes in how they feel and function. And you can observe this in biomarkers. I mean, you can biopsy the stool and look at the stool before and then after. You can look at several biomarkers and through blood testing, and you can get a better idea of how someone's doing. And then you can also just ask them and see how they're feeling and functioning. And a combination of those things together, what I'm getting ready to tell you does appear to play out clinically. Now, we'll see with the research, and in today's environment, you do want to have as much information as possible so that you make the right choices. But I will say that the interventions and the things that we'll talk about in our next segment are going to be very low risk for people, and it's not like you're taking a drug that could have a very serious side effect and permanently damage you. We'll talk about some of those interventions, but the research suggests to us that there is a low-risk microbiome, meaning a healthy microbiome that helps our immune system to function more optimally when we're exposed to viruses. So let's talk about some of the characteristics. A good, healthy microbiome, hypothesized by the researchers, is that it would or will produce high levels of regulatory and effector molecules. Now remember, these are things that influence the immune system. These bacteria, the microbiome, influences the immune system in a positive way. There are a lower level of inflammatory molecules that encourage an inflammatory response. So you've got this more of a lower, an immune system that is not primed for inflammation. And what they observed is that this results in an immune system that's well trained, well educated, and it protects the host. So the immune system responds appropriately. Now, on the other hand, they identified a high-risk microbiome, and this was basically dysbiotic, meaning what they believe is an imbalance in the gut microbiota. And this microbiome is characterized by low levels of these regulatory molecules, these molecules that help to regulate the immune system, so low levels of those, and high levels of pro-inflammatory molecules that may lead to an inappropriate immune response. And this could be like high levels of cytokines, these chemical messengers made by the immune system that actually signal immature immune cells to change into different types. And this could shift the immune system more towards a pro-inflammatory state. And this may lead to delayed viral clearance or hyper-inflammatory responses, so an over-response of inflammation, which are all believed to contribute to the severity of long COVID. So you can see if we can identify some of these characteristics, we can work on improving them. We may see some profound changes. And I think that this is something that is absolutely worth looking into. So let's talk about this, and let's characterize, again, this high-risk microbiome. Let's do this one more time so we can be clear here. High-risk microbiome that is hypothesized to be unfavorable, right, that you don't want, is a microbiome that produces low levels of regulatory and effector molecules. So those molecules that help to regulate the immune response and really help the immune system to function appropriately. Second, there are high levels of these pro-inflammatory molecules, these things that actually encourage an inflammatory response. And this is important because these factors are going to set the stage for, a more, or I should say, a scenario where someone would probably not respond appropriately when their immune system sees a virus. And this could delay viral clearance, and the hyperinflammatory responses can have, if you have a high response or an inflammatory response that is too much and that it doesn't resolve, then it could absolutely create a number of problems as well. So this may come down, like these different microbiomes may come down to the difference in diets long term. And I think this is so fascinating. So they're basically saying here that the low-risk microbiome and the high-risk microbiome, the difference in the two may come down to dietary habits long term. And this is something I think I wanted to emphasize this. This is also associated, this high-risk microbiome, the one that we think is probably not a good microbiome if you have long COVID or, just for your immune system and your immune response in general, that this is also associated with socioeconomic deprivation. So people that don't have the financial resources to eat healthy, real foods and are, likely consuming far more cheap processed foods, they are going to likely have a microbiome that is of the high risk type. And this is something that we really have to focus on changing. This is not acceptable. It's not acceptable that health is only for people that have resources. I really feel strongly that we've got to teach people how to raise food, be in communities or communities to come together to have like community gardens and whatnot. But we have to do better. And this is a really complex topic that I don't know the answers to, but the socioeconomic deprivation is 100% a critical aspect of this that we have to do better. Because the difference in someone being, born in a different in a different location to a different family in a different area, different country, whatever it may be, a different circumstance is purely chance. And everyone needs to have opportunity. I think that's something that we've got to ensure is that everyone has opportunity, and that we give children what they need to have an opportunity to function well and be healthy and overcome any challenges that they may be born into. And so this is something that I think is very important to consider, and I wanted to absolutely mention that because we have areas in the United States and I'm sure around the world, but I'm more familiar with the U.S., but around the world where there are food deserts and where people cannot get healthy healthy vegetables, fruits, and higher quality foods. And this is something that really needs to be acknowledged, and we need to try and do everything that we can to overcome those challenges, because it's not fair to these people, and we've got to do a better job. So that's something that does need to be mentioned. So it's really important, I think, that we step back and look at this and make note that there are a lot of different factors, including diet and these socioeconomic factors, that can influence the composition of the gut microbiome. And this understanding these factors can really help us to develop targeted strategies to restore and balance the gut microbiota as a whole. So pulling it all together, gut dysbiosis, which is an imbalance in the gut bacteria, very likely plays a significant role in long COVID, and particularly its neurological manifestations. The inflammation that's created with this gut dysbiosis or imbalance, along with this shift, remember the shift in tryptophan metabolism away from serotonin and towards these neurotoxic peptides, has a significant impact on our immune responses and could have significant implications for the severity and duration here of long COVID. So I hope that you're starting to see this really important impact of the gut microbiota on the immune system. So what we're going to do is, in the next segment, we're going to explore this functional medicine approach to optimizing the gut microbiota and how they may actually potentially alleviate the symptoms of long COVID by focusing on this critical, let's just call it what it is. I think it's more of a metabolic organ in our gut microbiota. In this segment, we're going to explore the role of functional medicine in modulating and improving the gut microbiota. We're going to discuss the use of prebiotics, probiotics, postbiotics, and how you can incorporate dietary compounds called polyphenols, and how these interventions may potentially alleviate the symptoms of long COVID. Now, just to be clear, a lot of the information that I'm going to discuss has been done in laboratory settings. It has been in vitro, so in a petri dish, or it has been done in animal models. And we see in a clinical setting that when we utilize strategies like those I'm going to discuss, we usually have positive changes in symptoms and in biomarkers. So though there is not a randomized, double-blind, controlled trial for many of the things I'm going to discuss, the clinical evidence and the animal studies and laboratory studies do suggest that there is some potential benefit for humans. But it's always important to point out the fact that a lot of the things that we discuss are theoretical and they are a work in progress. But my opinion is if these interventions and things that we talk about, if they have a relatively low or a very low risk, and we're dealing with health problems that other people or our physicians or medicine in general don't have any answers for, then I would rather look at the research that's out there and start coming up with some ideas and strategies that might be beneficial to help improve my health, because if I don't, then I'm just kind of stuck where I am. I would rather look at some of these things and make decisions for myself. And when more research comes out, great. I will use that to try and help determine what might be the best approach. But for me, as an individual, I would prefer to be able to make that decision for myself. So as we go through this information, keep this in mind. Now, in case you're not familiar with functional medicine, it is a form of medicine that focuses on identifying and addressing the root causes of diseases. And, I think every doctor, whether it's allopathic medicine, which is like the traditional model of medicine that you might think of, everyone is looking for what's wrong and what's causing the problem. Unfortunately, modern allopathic medicine, in a lot of ways, has become a disease management type of care. And it's not the fault of the doctors, it is just the simple fact that so many people are sick that the doctors are using tools to help manage their symptoms and problems, because most of the diseases that you see out there, a lot of them are diseases of diet and lifestyle, poor habits. And those are things that your doctor maybe doesn't have training in, but they're not going to be able to change typically in one visit. And they have really become disease management professionals. And you know what? We need that. But at the same time, the emphasis and the focus on what's causing these problems and how to make changes is very important. And that's really what, that's what I do. That's what I want to try and convey in this segment in particular on how you might be able to potentially support long COVID. And that's important. Again, potentially support. We don't have evidence for a lot of this information. However, again, in a clinical setting, this seems to work. And a lot of the research that has been done and that is being done points to this as a potential intervention to make a difference. So in the context of gut health, which we've been talking about, functional medicine interventions like I mentioned earlier, prebiotics, postbiotics, probiotics can play a real significant role, because in functional medicine, one of the most common areas for dysfunction is the intestinal tract and the digestive tract. And this can be a significant area of dysfunction that creates systemic effects and that can change the immune system and change the nervous system and have impacts on the endocrine or hormonal system. So this is a very important system. And anywhere that any of the systems where you have the outside world meeting the inside world, you're going to have the potential for an inflammatory response and immune dysregulation to occur if there's a problem there. So, for example, in the gut, if we have inflammation in the gut, if we have disruption or leaky gut is the lay term, the scientific term is intestinal hyperpermeability, where the intestinal lining becomes dysfunctional and it lets things into the bloodstream that shouldn't be there. You're going to have problems with an inflammatory response. You're going to lead to issues with immune system dysregulation. So from a functional medicine perspective, the gut is something that we look at all the time because it is such an important cornerstone to improving immune system function. So from this functional medicine perspective, prebiotics, probiotics, and postbiotics, which we'll get into what these are, play a pretty significant role. You can utilize them to help support the gut, and again, clinically we see that this tends to make a positive difference for most people. Now, these substances, when you consume them or when they're produced by your gut bacteria, and postbiotics are, for example, one of the things that are actually made by your gut bacteria, whenever they're consumed or they're produced by the gut bacteria in adequate amounts, they can actually promote the growth of beneficial bacteria. And this can also, you can feed like the good bacteria with some of these things like the prebiotics, which is kind of like the food for the bacteria. And if you're nurturing and feeding enough of the good bacteria, then they grow and they outcompete the potentially harmful bacteria. And this also can have, a modulating effect on the immune response. And if you remember from our one of our previous segments here, I discussed the fact that there are specific types of immune cells called antigen-presenting cells, and these cells will actually make their way to the intestinal lining on the blood side. If you think of it that way, you've got this one cell wall thick barrier. And on one side, you have the contents of the intestinal tract, and on the other side, you have the bloodstream and the immune cells. And this antigen-presenting cell makes its way to this one cell wall thick lining. It sticks in a projection or an appendage-like from the cell into and between the cells that line the gut, and it samples the intestinal environment. And then it takes that information back to immune cells where it is processed, and the immune system is trained and is modulated based on what is present. So if you have a favorable gut bacteria or microbiome, this is going to theoretically mean that you're going to have a more appropriate immune response. Just one of the many ways that this might modulate the immune system. Now, these various factors may actually be the key to improving the immune response in people with long COVID. And this may improve that immune response and have a positive impact on some of the symptoms that they're experiencing. Because again, this is a systemic inflammatory response. And again, there's many different things that could be happening here, right? There could be chronic inflammation. There could be the activation of an autoimmune process where the immune system is now attacking various tissues. There could be a number of different problems that have started or that are ongoing as a result of the SARS-CoV-2 infection, or the consequences of taking medications or other things that may have disrupted the gut microbiome, and that may be contributing to the persistence of these unwanted COVID long haul symptoms. So let's start looking at these tools a little bit more closely. And let's start by talking about prebiotics, because remember we said, to support the gut, there's a few things that we can do. And we're going to talk primarily about dietary interventions. I want to say that, supporting your health, you really have to take an encompassing approach that encompasses as many aspects of your life as possible. What I mean by that is, what is your routine like? What is your sleep schedule like? How are you sleeping? What is your stress like? How how are you quantifying your daily stress? How are you tracking any of that stuff? You've got to look at exercise, and I would recommend even looking at biomarkers like heart rate variability to help you understand if you're in a more sympathetically activated autonomic nervous system state, which is more of like a fight or flight state, or are you in more of a resting state? And heart rate variability can be a helpful tool to give you, first establish a baseline, and then kind of see how things are changing with targeted interventions that you're trying to utilize to help you improve your health. And so you want to look at your overall lifestyle. And that's a really important thing that you need to take inventory of initially. When I work with people one-on-one, I work with people via one-on-one, via telemedicine, and that's one of the things that I do is the initial consultation that I do with people is extremely in depth. I mean, we take a lot of information, a very thorough symptom assessment. We look at their a lot of their daily habits. We do a food journal. We look at a lot of things so that we can gather as much data as possible, analyze that data, and then come up with some strategies to support what we believe is a diet and a lifestyle that is more congruent with optimal health. And so we can take biomarkers. We can do testing to look at blood, to look at stool, to look at all these things and give us an initial starting baseline to help us create and tailor a more specific and unique plan to the individual person. And that's really like a more of a precision lifestyle medicine approach. And that's what ultimately you need to take that into consideration. And then you can look at specific tools like we're going to talk about, which granted, you could probably utilize these tools I'm going to talk about and continue your current diet, lifestyle, and not make any other changes, and it may be beneficial. It may be. However, my overall recommendation for most people is going to be to take an inventory of everything and then try to optimize as many aspects of your life so that you can improve your overall health. And this has a profound influence on the GI tract, your stress hormones, and on your ability to be adaptable and for your immune system to be healthier. So I want to just mention that and make sure that that's abundantly clear before we get into discussion of these tools that I mentioned, the prebiotics, probiotics, and postbiotics. Okay, so let's talk about prebiotics and how prebiotics may be able to help the gut. So prebiotics are special types of dietary fibers and other types of compounds that are found in our food, like polyphenols. And I'm going to discuss polyphenols in more detail in just a second. But these things, these fibers and these different compounds in our food, they don't necessarily give us any type of specific nourishment. They're more like food for our bacteria, for our gut bacteria. These are not digestible by us, but they can absolutely feed our bacteria and stimulate the growth and the activity of different populations of these bacteria. And what is believed to be a more ideal gut microbiome is one that is very diverse and that is abundant. And this is what we would consider as more of like an ideal I guess you would just say ideal microbiome. And that's what a lot of the laboratories that do comprehensive stool panels, they compare the sample that's sent in. So for example, if you did a stool test, they would compare your microbiome and the species there to what is believed to be more of an ideal, robust, diverse microbiome. And for the most part, I agree with that. The diversity of the gut microbiome, these bacteria convey a lot of different benefits to us systemically. Again, with the way that the bacteria it acts as a metabolic organ, and it produces vitamins and postbiotics and all these short chain fats and these things that help to modulate the immune response and keep our gut healthy and do a lot of amazing things for us. And I do want to acknowledge the fact that I'm talking about eating like diverse plants and vegetables, and I'm not against consuming animal sources of protein. I do recommend animal sources of protein. I'm not opposed to people following vegetarian diets or vegan diets. It just depends if someone has a particular aversion to, let's say, eating meat. Well, I would like to, if I'm working with someone, then I will always ask them, well, okay, what's your aversion? And if it's something like they just think that it's healthier to eat, plants, then we could have a discussion. I think that might not be. I mean, you can do it. I think you can do it. You can eat plants and get enough protein and everything, but it's definitely more challenging to do that because of the amino acids that you have to consume, the amount of protein that you have to consume from plant-based sources, and you have a different amino acid profile in plants versus animal sources. And you can definitely, I think you can do it. and people do it and do it well, but it's more challenging. Now, if it's more of like a concern about animal welfare or just the pain and suffering of animals, then that's something that I'm not going to debate that. I don't think that is a good thing either. I think that we want to treat animals very humanely, and that's super important to me as well. But there is an entire movement of like carnivore diet, people that follow a carnivore diet, or people that follow various dietary patterns. And for example, the carnivore diet doesn't have any of the stuff I'm talking about really in it. I mean, it has, there are, I'm not a carnivore specialist, but I know enough about it to know that it has helped a ton of people. Jordan Peterson, Michaela Peterson, Sean Baker is fantastic. I recommend that you check out their channel. But the carnivore diet, I would love to see. I know that Sean Baker's group, they're doing a lot of studies on this, and a lot of people have been carnivore, and it has absolutely changed their life. And it doesn't have a lot of these polyphenols or compounds, though there are fibers and things found in meat, and it really has been a game changer for so many people's health. And so I definitely would, love to see and learn more about the carnivore approach, because I think, at a very minimum, I think in a short term, it's probably a fantastic elimination diet for a lot of people. But I know I've seen people that have been on it long term, which, you typically think of an elimination diet as being a short term intervention that you utilize to improve the health and recover health. And then the idea is transition back to, a healthy diet that is more like probably a Mediterranean style. That's, I think, most likely, based on the evidence that's out there, that's one of the best dietary approaches to follow. Now, the carnivore diet, though, again, as I said, it doesn't have nearly as many of these things that we're talking about here, these flavonoids, these prebiotics, though there's definitely some there. So it's a controversial topic. Everything that we're discussing here is a bit controversial, but at this time I lean more towards a dietary approach that's more like a Mediterranean diet. After you've done like an elimination. Often when I work with people, and I start at the beginning, depending on what's going on with them, very frequently we'll use some sort of elimination diet. Usually it's not a carnivore diet. I've never used that, though I've heard great things about it as a temporary elimination strategy. But I still think that those gut bacterial populations that we're talking about here need to be diverse, and there need to be many of those. And I'm completely open to. I've used that strategy clinically with people where we increase the diversity of these fibers. We eat more fiber, and we get more of these polyphenols, and people usually do better. They usually do significantly better. But I'm open to the fact that if that as we learn more, and if carnivore is a really fantastic way to approach it, then I am definitely open to recommending and considering carnivore as a carnivore diet as a strategy. But right now, based on my experience, and again, I haven't used like a carnivore diet. I lean more towards like a Mediterranean diet as a longer term strategy for health and maintaining a microbiome at this time. And again, as with any of this information, I am open to changing my mind based on new information and data that comes available. So don't want to belabor the point there, but I just wanted to, before we got into prebiotics, talk about some of these other things that need to be considered. It's not just like you're going to use prebiotics or probiotics or these postbiotics and necessarily fix everything. Though it may, every person, you really need to look at what's happening with every person on an individual basis so that you can tailor the strategy that you're going to use to their unique needs. Though there are often some standard things that you can do across the board that will improve people's health and help them to improve their gut. So let's get back to, I kind of got sidetracked there, but let's get back to talking about prebiotics. And they're these special fibers, and they're dietary fibers. There are other compounds in our diet like polyphenols, and these act like food for your gut bacteria. They will feed selectively, different types of polyphenols will feed different groups of bacteria more so than others, because some bacteria will consume polyphenols and others will not. That will typically lead to improving the good bacteria and helping the good bacteria to overgrow and outcompete the unfavorable bacteria. So it tends to set the microbiome up in a way that is less inflammatory, that produces more of these postbiotics that are helpful for a better immune response, and it tends to be overall better for us. Now, the thing with the polyphenols, they really help to support these good bacteria, and you can find polyphenols in a lot of different foods, primarily fruits, vegetables, some grains. But there are subtypes of polyphenols, and one of the things that I think is important is to understand some of the subtypes of the polyphenols, so that you can get a better idea of specific foods that you can eat to increase these. Now, one of the things that I want to focus on are the different types of polyphenols, and you can find these if you look them up online, like food sources. But I'm going to try to give you a few here. And so I just want to go over first just the 5 different polyphenol groups that we're going to discuss. Okay, so remember, these are typically colorful. These compounds in fruits and vegetables, also in grains and legumes, that make them colorful. Okay. So the 5 polyphenol groups that we're going to discuss are flavonoids, phenolic compounds, stilbenes, lignans, elagitannins, and ellagic acid. Okay? Now, the most abundant type, the ones that you're going to find the most in nature, are flavonoids, and you've probably heard of some of these. The most, I guess, common, the ones that you'll hear most commonly, and the one that most people are probably familiar with, is quercetin or quercetin, depends on how you pronounce it. But it's found in things like onions, apples, berries. It's found in some teas as well. You may have also heard of catechins, and the catechins are found in green tea and chocolate. And then another group of flavonoids are anthocyanins, and they're found in berries, cherries, grapes, and also some in red wine. Now, some of the potential benefits of these flavonoids, remember, which are a type of polyphenol. Some of the potential benefits may be, again, remember, our research, we have animal models, we have in vitro studies, we have very little human studies. But again, clinically, this tends to be, and this usually does, we do see improvements when we incorporate more of these into our diet. Some of the benefits that have been observed are potential for improved heart health, the potential for reduced inflammation, for improved memory, for different types of cancer that they may be supportive, to reduce the risk of osteoporosis, and then also to help with the regulation of blood sugar levels. They can even have some effect that way. So, when you look at some of these things, you're like, this is amazing if compounds in foods can really do this. And I think this kind of comes back to that quote that let food be thy medicine. And I think that is incredibly true, and an important statement is that our food, we need to eat the best and the highest quality foods that we can, and let that be our medicine, because our bodies are designed to thrive off of real food that's in our environment, and not highly processed foods. So flavonoids have a lot of potential health benefit. Now let's talk about the stilbenes, which again, remember, the stilbenes are polyphenols, another subtype of polyphenol, and they have a different chemical structure. They're found in a lot of different types of fruits, including grapes, berries, and strawberries. And you're going to hear that, as we talk about different foods where you'll find these things, you're going to find them very commonly in colorful foods and colorful fruit. So some of the potential health benefits of these Stilbenes, and again, remember, I'm going to reiterate this. We have animal studies, we have in vitro, so like in a lab setting, but not in vivo, not in human studies for most of these. Now there probably are some studies, but I don't know all of the evidence. I just know the information and the utilization of a lot of these compounds in practice, getting people to eat more of these foods, follow more of like a Mediterranean style diet. And you can utilize some of these things as supplements temporarily if you're really trying to ramp up your intake or if you're having problems getting them from food. But we see that clinically there are often benefits from taking these or utilizing or increasing our intake of some of these substances. So potential health benefits include reducing potential reduction of inflammation, potential improvement of heart health. There may be some support benefits to different types of cancers, reduced risk of osteoporosis, and can potentially enhance mood. And so these things are, really can be incredibly helpful. Now, the next type of polyphenols are called phenolic acids. And phenolic acids are, again, a type of polyphenol. They're found in a wide variety of fruits and vegetables and whole grains. And these things can also have real significant positive impacts on our health. Very similar to what you see with the flavonoids and the Stilbenes. Now, some specific types of these phenolic compounds or phenolic acids are hydroxybenzoic acids found in tea and red wine. Hydroxycinnamonic acids found in coffee, blueberries, kiwis, plums, apples, and cherries. So these are again, you see a lot of similar foods, and that's kind of the good news is that you get a lot of these different compounds. One of the best ways to approach this is just try to eat the colors of the rainbow every day. That's at least a good strategy that I utilize that seems to work. So the next one that we want to talk about the next type of polyphenol are lignans. And lignans are found in seeds, particularly in flax seeds, as well as grains and some vegetables. And then the last grouping that we want to talk about are ellagic acid and ellagitannins. And these are found in certain fruits and nuts. And the ellagitannins are commonly found in pomegranate seeds, raspberries, strawberries, and walnuts, and then ellagic acid is found in raspberries, strawberries, and walnuts. And just keep in mind these polyphenols have this gut supporting effect. These different colonies of bacteria and can have a significant impact on our systemic health because of their complex interaction that we see between the gut and the brain and the gut and the lung. Now, just remember that the best way to get a variety of these things is to consume a diverse diet that's rich in different fruits, vegetables, whole grains. If you're not reactive to those, I do not recommend gluten-containing grains, and then nuts, as long as you don't have a problem with those as well. So those are prebiotics, and that's a lot, right? There's a lot from prebiotics, but the prebiotics actually feed the gut bacteria. So the next thing we want to talk about are probiotics. Now, probiotics are living and non-living microorganisms. Most often it's bacteria, but it can be some yeast as well, like Saccharomyces boulardii. But different types of probiotics or organisms or bacteria that may have health benefits when they're consumed. And they're found in a lot of different foods, and I would highly recommend that to get your probiotics, try to get them from food first. Remember, if you can use food first, that's great. If you're like, I'll eat the foods, but I also want to try to ramp up and increase my progress, then maybe a supplement is appropriate. But oftentimes I don't start people on probiotics. I try to get them to change their diet, feed their bacteria with these polyphenols and these different fibers in their diet, and then eat some fermented foods. So they're found in things like yogurt, in one of my favorites, which is kefir, as long as you don't have a sensitivity or allergy to dairy or casein. Or you don't have a problem with lactose, which kefir is a little bit lower in lactose because it's fermented, but kefir can be a fantastic way to support your gut bacteria as long as you don't have a problem with it. And dairy products are very commonly problematic for people that are autoimmune. They tend to drive an inflammatory response if the proteins in the dairy pass through the intestinal barrier into the bloodstream, partially digested into what we call peptides. That can trigger an immune response, and if you make antibodies against the dairy protein, like casein or partial protein or what we call peptide, then there is a potential for autoimmunity through immune mechanisms like what we call molecular mimicry, where the antibodies in the blood that should only attach really to the casein protein, which the immune system might observe as foreign. Again, everyone has their own unique immune reactivity or tolerance or lack of tolerance to foods and food proteins. But if you do react to it, you may produce antibodies against it that then circulate throughout the bloodstream. And if any of your tissues look like the protein or part of that protein in the casein, which is the protein from dairy, then they may be able to bind to your tissues, and that can be something that either initiates or perpetuates and drives the autoimmune process. So we find a lot of times following a diet that is lower in antigenic foods, which means antigenic just that it would stimulate the immune system. If we can eat a diet that's low antigenicity, then it tends to be helpful as well at calming the immune system and decreasing the inflammatory response. So a lot of times we can recommend like diets, like an elimination diet, and then gradually reintroduce foods while we're doing some things to help improve the gut barrier and try and support the immune system, support any deficiencies that we might find. But if we have a budget to do food sensitivity, food allergy testing, then we definitely will do that to give us a more unique fingerprint for that person, so that we can then say, okay, look, keep this food out for a period of time, keep this food out for a period of time, because you're showing like an IgE reaction, which is a true allergy, or maybe you're showing an IgG reaction, which may be like a sensitivity, which is something that you don't see right away, but that's still driving a response, and do that for a short period of time to try to reduce the immune response and help the body to recover more quickly. And in clinically, we tend to see that does work. But these fermented foods can be fantastic for you: yogurt, kefir, pickled vegetables, kombucha. Tempeh can be helpful. Kimchi can be fantastic. My two favorites are probably kimchi and kefir. And the kefir is not the kind with no sugar added, so it's not sweet. It tastes like thin sour cream. So no one really loves that. but it's fine. It's still fantastic for you, as long as, again, you don't have problems with the lactose. You don't have problems with the casein. It's usually really good for you. So some probiotic supplements. I mean, there's a ton of different probiotic supplements that are out there on the market, which may be helpful. I do use them sometimes, but usually not for really extended periods of time. Again, you want to try with food, and you want to try to support your microbiome. But this is where it's always good to get a baseline for what's going on with you. And if you can do a really good, comprehensive, expanded stool panel that surveys a whole bunch of different markers, looks at your short chain fatty acids, looks at your for potential pathogens, both bacterial, fungal, parasitic. All those things are great if you can get that as a starting point, because then you can then tailor more of your strategy based on your findings, and then you could retest those things in the future to kind of see what kind of changes are being made. And that can be a really good way to test, implement a strategy, and then you reevaluate, and then you can change the strategy again and tweak it as needed, and then you can retest and do that a few times, and that will help you to kind of peel the layers of the onion to see if you can improve your health or your gut microbiome and make progress in that way. And that tends to be a very good and reasonable strategy. So these probiotics have been shown to help improve digestion, boost the immune response or improve the immune response. And now you understand why, right? Because favorable bacteria create favorable metabolites like short chain fats. They make different vitamins. They can outcompete the bad guys, the bad bacteria. And all of this can kind of set the stage for a better immune response. And we've talked about, quite extensively about how that and why that might happen. But this can help to reduce inflammation, increase nutrient absorption, regulate hormones better, and improve gut health. So it can be really, really helpful. Probiotics can make a huge difference, and so I definitely recommend that you're trying to consume fermented foods as one strategy. That can be a great way to do it. And as with all of the information that I'm sharing with you, you have to make sure to speak with your doctor first to make sure that any of these things that I'm suggesting are right for you, because you have a unique and individual scenario that has to be honored. So don't go making any changes, taking any supplements or anything without talking to your doctor first. If you need help and you need someone else on your team to help you figure this stuff out, then you can always check out my website. I work with people around the world via telemedicine, and I'd be more than happy to take a look at your case and see if it's something that I might be able to help you with. And if it's something that I don't think I can help, which I have that a lot. There are a lot of cases that come in that I'm really I feel like I'm very proficient at most things functional medicine, working with the gut for sure. I work a lot with Hashimoto's thyroiditis, and I work a lot with psoriasis. So those are things that I have lots of experience with, and I feel very comfortable with those issues. If there are other issues that come up, then and I can't help, or I don't feel like I can help or do the best service for you, then I would absolutely try to point you in the right direction. But these probiotics, these bacteria, can be really, really helpful. Now, the last intervention, right, that I want to talk about here is, or I should say are, postbiotics. Postbiotics are really interesting. These were, these I think have become better understood within the last 5 years. And postbiotics are these compounds that are produced by bacteria during the digestion of food. So these compounds include things like short-chain fatty acids, different types of peptides that the bacteria make, antimicrobial metabolites, things that actually metabolites that help to fight off bad bacteria, and then other types of molecules with a ton of different health benefits. So these postbiotics are really an exciting area of science, because there's so much potential for them. Now, they play a really important role in the gut health, as we've talked about. I think I've covered this a few times, but they can help to maintain a balanced microbiome. They support the immune system. They support the intestinal lining and the health of the intestinal tract. They can have anti-inflammatory effects and reduce a lot of the risk factors for different types of diseases. Now, they hold lots of promise, and I think probably the most famous short-chain fatty acid is butyrate, and it has been shown, there's a lot of research on butyrate out there, but it can be a really powerful postbiotic, and it can help to heal the gut lining. I mean, I do use short-chain fatty acids and predominantly butyrate sometimes in gut support protocols, supplementation protocols, along with diet, in the short term, to try and help improve the GI tract health, integrity of the intestinal lining, and see if we can't support more optimal and faster healing of the gut. So they can be really helpful. I've seen a lot of benefit, in clinical practice there. But moving on, one of the things I wanted to cover, and in particular as it relates to long COVID, are some specific types of probiotics. There was some research done that showed that there were two types of Bifidobacterium longum. Okay, Bifidobacterium longum. Namely, there's two different strains, and there's a number associated with them. So, Bifidobacterium longum 35624 and Bifidobacterium longum 1714. These two particular strains were shown to be particularly helpful at improving gut health and their ability to help modulate the gut-brain axis. And that could potentially improve the overall health status of people suffering from long COVID. And these what the researchers found and what they believe is that they appear to help with the health of the mucus layers that line the intestinal tract, which we know are critical for an optimal GI tract bacterial or GI tract barrier. But it's also critical for optimal immune system function. So it actually helps to support the mucus layers, and I think that is something that's really interesting, because you have bacteria that will make mucus, then you have bacteria that will that will feed off of the mucus, and there's this symbiotic relationship where they all work together to keep the intestinal lining healthy. So to pull it together here and wrap it up, functional medicine, it really offers a variety of approaches that could help to potentially modulate your gut bacteria or your microbiota and provide support for people that are dealing with long COVID. Now, is this going to work for every person that tries it? I don't know. I mean, I think that it would help. And if I was working with someone that had the symptoms of long COVID, I would look really closely at their gut. I would look very closely at their vitamin and mineral status. I would look very closely at inflammatory markers. I would look very closely at their lifestyle. I would get them to, if it's all relative. It's like, well, if you have the budget to do certain things, we would get testing, and I would recommend biometrics tracking at a minimum, some type of either a smart ring like the Aura, or a Garmin watch, or an Apple Watch, or even there are so many different biometrics tracking watches and things out there that would suffice and that would do a great job. But something to do biometrics tracking, so we could track sleep, we could track movement, we could track heart rate variability. We could really look at a lot of different aspects of health and see if we're moving the needle in a positive way or not with the interventions that we're attempting. So I think that it's really important to keep in mind that further research is really needed to understand and really get to the bottom of these mechanisms involved in promoting long COVID, and to help us so that we can establish the most effective strategies for each person, because each person is going to present with a slightly different need than another, and sometimes maybe vastly different needs than the next. So this is something that I wanted to share with everyone. I think this is an incredibly important topic, and I've gone far, far longer into this than I thought I would, but I hope that this particular segment in particular is helpful without being more redundant, that this is helpful and gives you some ideas of things that you can do. So diverse diet, potentially looking at supporting adequate fiber, plenty of polyphenols, a general diet, just in general. If I was going to say, what do I currently think is probably the best diet for optimal expression of human health, it's probably a Mediterranean diet. I think that's where most of the literature is. But there are a lot of other dietary strategies out there that could be better. I don't know for sure, but just clinically and what I've learned over the years, that is usually one of the better dietary strategies. But each person's an individual, and you would want to approach their situation based on their history and what they've reported has worked or not worked in the past, and try to come up with the best overall approach that you can. I think that focusing on improving gut health could be a powerful tool to help people recover from long COVID. I think that a lot of the research is suggestive of that. And I just wanted to encourage you, if you have any questions or you need any help, please don't hesitate to reach out, and I'll do the best that I can to help you. But I do appreciate you hanging out with me, and I hope that this information helps you to improve your health and live the best life possible. If you found this episode helpful, please share and leave a review. It really helps the podcast. And as always, don't forget to subscribe so you don't miss an episode. You can also follow us on YouTube and Facebook at the Office of Dr. Brad Shook. You can join our Facebook group, the Greater Hickory Thyroid Support Group, with over 11,000 members, and you can find me on Instagram at Dr. Brad Shook. And remember, together, we can make a difference. As we wrap up this episode, I want to leave you with this thought. Our bodies are complex, interconnected systems, and when one part's out of balance, it can affect everything else. If we can understand and address the root causes of our health issues, we have the potential to improve our quality and quantity of life. If you're struggling with a health problem, remember you're not alone and there is hope. I really appreciate you spending this time with me today, and I look forward to hanging out with you in the next episode. Until next time, take care. Thanks so much for listening. We hope you enjoyed hanging out behind the scenes with Dr. Shook. You can also talk with and learn from Dr. Shook through Facebook Live on our Facebook page at the Office of Dr. Brad Shook. Don't forget, you can also get access to our videos, guidebooks, and thyroid programs at www.drbradshook.com. Oh yeah, and don't forget one more thing. We can change the world one person, one family, and one community at a time. Until next time, remember, today is your day, and no one will tell you who you are and what you can be.